Today we're going to get into special products of polynomials. So our learning goals, I will use patterns to multiply polynomials. And the thing about this section is really you can get through things without having this kind of stuff memorized. However, in the second half of the chapter, we're going to be talking about factoring, which is basically undoing all of this stuff that we're doing at the beginning of the chapter. And if you don't begin to recognize these special products and these special patterns, that factoring is going to be substantially more difficult. So we're going to just go over a couple of things, but you can always use FOIL or one of the other methods to multiply things out if you don't recognize the special products. So the first thing we're going to look at is when you have something that looks like this. A plus b times a minus b. So you'll see my first terms are the same, my second terms are the same, but in one part we're adding and one part we're subtracting. So an example of what this might look like would be like x plus 2 times x minus 2. So first of all, let's just start off by foiling this and see what we get. If I do x times x, that's x squared, so that's first. Outside is a positive x and a negative 2, so that's negative 2x. Inside is a positive 2 and a positive x. And then last is a positive 2 and a negative 2, which make negative 4. And when I combine these, my middle terms are going to go away. So I just end up with x squared minus 4. So let's look and see what would happen if I FOILed a plus b times a minus b. I'm going to do that in a different color. So a plus b times a minus b. So first would be a times a, which is a squared. Outside is a positive a and a negative b, so I'd be subtracting a times b. Inside is b times a, but remember with my commutative property, I could write that as a times b, so that's what I'm going to do. And then I have a positive b times a negative b, which would mean that I'm subtracting b squared. So again, if I look at my inside terms, I have a negative ab and a positive ab. Those make 0. So I end up with a squared minus b squared. So what that is telling me right here, anytime I have the same first term, the same last term, but one's being added and one's being subtracted, that will always work out to give me a squared minus b squared. So I can use that then to make my life a little bit easier so I don't actually have to multiply. If I have k plus 9 times k minus 9, I know that that's going to work out to be my first term squared minus my second term squared. K squared minus 81. And again, I could have used FOIL. I would have gotten k squared minus 9k plus 9k minus 81. My middle terms would have canceled, and I would have gotten to this point anyway. But the goal here is just for you to recognize this pattern. This is my first term squared. This is my last term squared. That's going to be important later on. A couple of sections from now in the second half. It'll work in a situation like this as well. 4q minus 3 times 4q plus 3. Same first term, same second term, one's being added, one's being subtracted. So when I do this, I want to remember it's my entire first term squared. So this is going to be 4q squared minus my last term squared, minus 3 squared. 4q squared, this means everything in those parentheses gets squared. So 4 squared is 16, q squared, and then 3 squared is 9. So this is going to simplify to 16q squared minus 9. That's 4q squared, that's 3 squared. So this pattern's pretty easy to see. This next pattern, a plus b squared, or written out would be a plus b times a plus b. And when people see this, they want this to be a squared plus b squared. That's how they, or when they see this one, they just write, oh, that's a squared plus b squared. That's not true. So let's go through and do the multiplication again like we did before and see what this works out to be. If I were to use FOIL, first would be a times a, which is a squared. Outside would be a times b. Inside is b times a, or again, using the commutative property, that would be ab. And last is b squared. So when I combine my like terms here, I have two of these ab's, but they're both positive now because these are all positive. So this gives me a squared plus 2ab plus b squared. So a squared, or a plus b squared, is not a squared plus b squared. When we square a plus b, we end up with a squared plus 2ab plus b squared. That middle term is very, very important, and people like to forget about it. So an example for this one, if I had x plus 4 squared, using this pattern right here, that becomes x squared plus 2 times 4 times x, oops, that'd be a, same thing though, plus 4 squared. Or to write this a little bit neater, x squared plus 8x plus 16. So something to look at with this is my middle term twice what a and b would be. So in this case, this is 4 squared. So b is 4, a is x, this is 2 times 4 times x. So this is another pattern that you're going to want to recognize. Same thing is going to work if we're subtracting. If it's a minus b squared, we're going to have a similar situation because this would be a minus b times a minus b. And again, this is not going to work out to be a squared minus b squared. People jump to conclusions and they say that and they get stuff wrong. So let's actually multiply it out and see what we get. A times a is a squared. I have an a and I'm taking away a b, so that's a negative ab. I have a negative b here and a positive a, so that's another negative ab. Here I have a negative b and a negative b, so that makes a positive b squared. So what I get here is a squared minus 2ab, because I'm taking away ab twice, plus b squared. So if I had, let's just use the same numbers, x minus 4 squared, now I'm subtracting, this is going to work out to be my first term squared, minus 2 times my first term times my second term, plus my last term squared. So I get x squared minus 2 times 4 is 8x plus 16. So if you compare my x plus 4 squared and my x minus 4 squared, the only difference is my middle term is positive here and my middle term is negative here. So these again are special patterns that you can figure out by using FOIL, but the better you get at recognizing them, the easier it's going to be later on when we're undoing these special patterns. Okay, I have 3 on your own problems I would like you to try before starting to work on your homework. Okay, so you should have tried these already, but for this one, this is using the a plus b squared pattern. So remember, that's going to work out to be a squared plus 2ab plus b squared. So in this case, it will be w squared plus 2 times w times 2, that's 2ab plus b squared, or w squared plus 4w plus 4. Here we have the square of a difference, so this is going to be x squared minus 2, so I'm subtracting now, 2 times x times 7 plus 7 squared. Remember, it's only the middle term that's subtracted. X squared minus 14x plus 49. So here I notice that's 2 times 7. That's 7 squared. So my eye is just going to notice that. And then this last one, it's going to be a squared minus 2 times a times b plus b squared. Oops, b squared is 1. So 3y squared is 9y squared. 2 times 3 is 6, times 1 stays 6, so minus 6y plus 1. And that's just how you're going to do those. And again, you can always FOIL them if you forget the pattern. And you know, you should be getting all of these right even if you forget the pattern, because you can always FOIL or multiply it out another way. So there you go.